Hello everyone. In this video I will show you some basics of the point cloud functionality in Pythagoras. First, make sure you download the data accompanied by this video and save it to a location that you can easily find, for instance your desktop. Unzip the file. You can see that it's a fairly large file, approximately 100 megabytes. The file that you downloaded has the extension PPC, which stands for Pythagoras Point Cloud. It's a format specially created for Pythagoras, optimized for big point clouds. The PPC file was created starting from a general format like LAS, LAZ or TXT. The process to convert LAS to PPC takes some time, so I left it out of this video and presented you with a file that is ready for import. Open up Pythagoras and go to File, Import, Point Cloud, and select the downloaded file. After a few seconds, the file is loaded and the point cloud appears on screen in the 2D window. Let's show the point cloud in the 3D window, which is optimized for viewing point clouds. Right-click and choose Open in 3D window. Once it's loaded, activate the Orbit tool and use the left mouse button to rotate the model. And use the right mouse button to change the camera view. We want to calculate the volumes of the stockpiles, so we need to calculate terrain models from the point cloud. Go back to the 2D window. I want the volume of this stockpile. We need to create two DTMs, one of the bottom and one of the top. We start off by creating a boundary. Select the line tool and start drawing the boundary. Pythagoras will automatically snap to individual points of the point cloud. Holding the Shift key is a good idea because the lines will be attached to each other. Then we'll create a polygon. We'll need this polygon to tell Pythagoras which area of the point cloud needs to be used for the terrain model. First, turn off snapping to the point cloud by going to Snap Info and uncheck the box near point clouds. Then select the Create Polygon tool and we click once in the enclosed area. Then I press Escape or I return to the Selection tool and I double click on the polygon. I change the pattern so that the polygon is visible. Select everything and then go to DTM New Terrain Model. Enter the name of the terrain model, bottom, and press OK. Press Yes to continue. After a few seconds, the DTM from the bottom appears. You can see the big triangles going from one side to the other. This DTM represents the bottom of the terrain. Now we'll calculate the terrain model with the point cloud included. Select everything again and go to DTM New Terrain Model. Enter the name, stockpile, and press the Change button. Check the point clouds checkbox, press OK, OK, and yes to the warning message. Then another warning message appears, warning about conflicts. This is because the lines we drew are conflicting with some points that lie right on top of or below the lines. The lines have a slightly different altitude, which gives conflicts when calculating a terrain model. Choose Yes to continue. Now you have to wait a bit until the DTM is calculated. If the calculation is finished, the DTM appears on screen. You see a big green area. Zooming in reveals very small triangles. Now let's do the volume calculation. Select the polygon again by clicking on it. This will fasten the volume calculation. Then go to TTM volumes. Change the method and change the number of x sections to 300. Now press calculate. After a while, cut and fill volumes appear. This stockpile holds 590 cubic meters of sand. I'll quickly show you some other possibilities with point clouds, section planes and drawing in 3D. This is a point cloud from a technical room. I use the orbit tool and the up and down arrow to walk around in the room. I'll show you how to create section planes from this room. I want a horizontal section plane. First, make sure I'm looking at the point cloud sideways. Then I select the Create Section Plane tool. What I have to do now is define 2 points that lie on the top and bottom section plane. I click once and press Enter to define the coordinates of the first point. Make sure the Z value is somewhere between the minimum and maximum of the point cloud. Then I hold the Ctrl key to make sure my second point is vertically above or below the first point. The line will turn blue. I click once more, press Enter, and now I have a section plane. I can move around the section plane by selecting the Move Section Plane tool. We'll click on the blue dotted line, which are the boundaries of the section planes. The planes become light gray, which means they are selected. If I click on the blue line and drag the mouse up and down, the section planes will move up and down entirely. If I click on a plane and drag the mouse up and down, I can move that plane separately. I can position the section plane in a way that I can easily draw the as-built floor plan of the building. I'll do this for the top floor. I'll first make sure I have a top view on the point cloud by clicking on this icon. Since this is a 3D viewer, the view is in 3D, which means perspective projection. Objects close appear bigger than objects far away. I'll change this view to an orthogonal projection via the View menu, which flattens everything. Now I select the Create Line tool and zoom in on the point cloud to start creating lines. I hold the Shift button to make sure all lines are connected. Once I'm ready, I return to the 2D window. I turn off my point cloud and see the lines that I just drew in the 3D window appear here. That's all I wanted to show you. Thanks for watching. If you have questions or remarks, you can contact us at support@pythagoras.net.